I, Tanchoo Hang Subba of Grade XII Lobuche, am here to demonstrate the properties of gases using PhET simulation. Today, we will learn how pressure, volume, temperature, and number of particles are related. Let's begin now. Let's study about gas pressure. As you can see, the reading is 0 pressure right now. Now when I release the heavy particles and light particles, when they collide with each other and the walls, we can see the pressure fluctuating. This is how gas pressure is created when two particles collide with each other or with the walls. Now, let's study about Boyle's law. The Boyle's law states that at constant temperature, pressure is inversely proportional to volume. P is proportional to 1 by V. In Boyle's law, temperature is kept constant and only volume is changed. Pay a close attention to the pressure right now. Let us keep the temperature constant. And now, if I decrease the volume, then you can see that the pressure has increased. And now, if I increase the volume, you can see the pressure has decreased. This proves the Boyle's law. Now, let us move into Charles' law. The Charles' law states that at constant pressure, the volume of a gas is directly proportional to its temperature. V is proportional to T. Now, in Charles' law, pressure is kept constant and only volume and temperature fluctuate. So let us keep the pressure constant. As you can see, when I heat, the volume increases, and when I cool it, the volume decreases. This shows the relationship between volume and temperature in Charles' law. Now, Gay-Lussac's law. Gay-Lussac's law states that at constant volume, pressure is directly proportional to temperature. P is directly proportional to T. In Gay-Lussac's law, volume is kept constant and only temperature fluctuates. So, now that the volume is constant, let us heat the gas. As you can see right now, the pressure is around 9 atm. When you heat the gas, you can see the pressure increase. And when you cool the gas, you can see that the pressure decreases. This shows the relationship between P is directly proportional to T. Moving on to Avogadro's law. Avogadro's law states that at constant temperature and pressure, the volume of a gas is directly proportional to the number of particles. V is proportional to N. In Avogadro's law, pressure is kept constant. So, there are 40 heavy particles and 40 light particles. When I add more heavy particles, you can see that the volume increased, but the pressure is still the same. This shows that V is directly proportional to N, meaning volume is directly proportional to the number of particles. Hence, from this simulation, we have demonstrated that gas pressure results from the particle collisions and that pressure, volume, temperature, and number of particles are all interconnected as stated by the gas laws.